Hi, my name is Bill Haberman, Intertest Incorporated, Columbia, New Jersey. We are providing this video to demonstrate some of the features and functions of the freestanding WebViewer in the cart-mounted configuration. There are other videos that depict a lot of the details of this system, so we will focus more on the meaningful aspects of being in a cart-mounted system as opposed to getting to the details of the system's operation. The freestanding WebViewer is a tool designed to examine the internal surfaces of components such as spools or drums, which are internal high-speed rotating components in aircraft engines. The tool provides high-resolution color video of the internal surfaces with both white and ultraviolet light. It is intended for use as a white light inspection tool and also as a visual inspection tool in the fluorescent penetrant process or in a mag particle process. Typically in a drum or a spool, it's the fluorescent penetrant process that we're looking at. The system operates by a single power point that is wound up on a horn on the cart. It can be deployed, and typically the cart will go out with 15 meters of cable. We hit the power strip with a single on point that enables all components to be powered on. At this point, I did previously power the control unit on. I can also turn on light sources. This is a white light source. The green one is an ultraviolet source. We provide two independent lighting channels so that ultraviolet light can be used, white light can be used, or they can be used simultaneously. Controls are affected by a control unit. There are motion controls, camera controls, and zero value controls for encoder positions. The freestanding WebViewer has a motorized lift for elevation. It has a motorized drive for horizontal movement, and it has a motorized drive for radial reach. So in the case of lift, raising the elevation of the horizontal bar. Typically that would be positioned so that you had complete clearance into the drum. We have control for horizontal translation. All of these controls have speed control, so I could run that down at very low speeds, or I can run it at high speeds. And we also have a control for radial reach. The camera is housed in this end effector. The end effector has the capacity to use 5 different optical adapters, so it can look in a forward view, it can look in a 90-degree retro view, it can look in a 90-degree forward view, it can look at a 60-degree forward angle and at a 60-degree aft angle. At this point, I have the 60-degree forward angle on the control head. The radial reach will allow the system to extend out. Typically, we will move into a drum or spool, get to the particular stage that's subject to inspection, and then affect radial reach to get the camera in position, looking at the various aspects or various parts of the web structure. The components that comprise a freestanding WebViewer system are all here, and I can point them out. We have a control unit that operates the camera, it operates the motors for motion control, and it also reads and converts the encoder feedbacks into positional information. Often it's convenient to operate at the target, at the spool. So we provide a remote pendant control. This is on a curly cord. The curly cord is approximately 3 meters. And all of those functions we saw just a moment ago can be run by these controls on the pendant. The cart is a powder-coated welded steel heavy-duty cart operating on hard rubber tires. It's 2 wheels castering in the rear, 2 fixed wheels up in the front. Monitor is on a, we call it a swing arm. It has the ability to be repositioned so that if you were at the other end and you wanted to watch the monitor, or if you're working from this side, you can watch it. You can put it in any position that's convenient, and it has an ability to change its elevation. There's also an ability to pitch it to ergonomically fit the operator and make it comfortable. So the display is a Sony high-resolution LCD monitor. We have the ability to superimpose on that monitor values of position. The position values may be repositioned on the screen, may be turned on and off, may be shown with a blank background or a background and put in 4 locations on the screen. We also can change the units of measure from centimeters to inches. With motorized systems, we have an emergency stop. The emergency stop would completely cut out any power to motors and freeze the system instantly. Essentially what we've done is we've cut power to the control unit as a stepper motor drive that is pretty much locking the position at the instant of powering down. Freestanding WebViewer, as I was saying, has several different optical tips. We have a 60-degree forward tip on there. Typically, they are supplied as a set of 4 or 5 and are provided in a kit as shown here. The cart does have a convenient drawer for storage of the support elements and other items that relate to the use of the inspection system. Driven by motors is an option. If this were not a motor-driven system, this section here would be replaced by a hand wheel, and this is driving the horizontal boom. The elevation would be replaced by a hand wheel, and that would drive the elevation of the whole horizontal boom. The WebViewer radial reach is always motorized. The freestanding WebViewer is designed to inspect the interior sections of spools or drums. The typical configuration of that inspection process is as shown here, where we have the freestanding WebViewer on a horizontal boom. That horizontal boom can make progress into a drum. While in the drum, we extend the radial reach camera down into this section and look at the web. The inspector would then rotate the drum through 360 degrees, or a little bit of overlap, retract the WebViewer, make progress into the next section. Repeat the process, extend the WebViewer, look at the surface, rotate the drum, translate the WebViewer such that there's overlap in that inspection of the web. After having completed that sequence such that we've covered all the surfaces, the WebViewer is retracted, and either the optical tip is changed to look at a different direction. For example, this would be looking at a 60-degree angle in that direction. So if we were in the drum, we'd be looking into the corner of the web section. This particular drum, the CF34-3, the 3/8 spool, there's no need to go in examining surfaces with the 60-degree adapter. We would be in with a 90 and with the forward view adapter. We also have the ability to, rather than changing the adapters, to rotate the drum and look at the opposite walls by, again, inserting the WebViewer into the appropriate section, extending in radial reach to the proper positions, inspecting the surface, rotate the drum, reposition the WebViewers in its radial reach position, rotate the drum, and continue that sequence until all surfaces on that side have been covered.